Hello, my name is Agniezska Mikołajczyk, and today I would like to tell you a bit about automated generation of keywords based from the NLP perspective. So I'm from the company called VoiceLab. I'm working there in the NLP team. So basically, I am a machine learning engineer. I work with data all the time at my university, but because I also come from the Agniezska University of Technology, I work a lot with computer vision, deep learning algorithms, and so on. And here at the company, I worked a lot with text and transcripts. So the text converted from speech to text. So today I will tell you a bit about automated keywords generation. So this is a little bit similar to the previous topic. So I will just put a stopper to not talk too much. What are keywords? So those are words that are significantly more frequent. So they are reoccurring in the given text corpus and so on. And they are basically defined as descriptors or metadata of scientific articles. But in our company, we wanted to use those keywords a bit more like a subject, so a little bit more similar to the previous presentation. We wanted to have keywords that will explain well what is going in the text. So that was our basic goal. And we wanted to limit it to 3 to 5 items, like a scientific article, we have abstract, and usually 3 to 5 different keywords. So this is what we wanted to do. So generating keywords from abstracts. And they can be identified extractively. So when they are exactly in the abstract, the keyword is in the abstract, it's extractive way, but if it's not in the abstract, it's a generative way. So we wanted to extract them and generate them both at the same time. Okay, so what did we want to create? So I already told you a bit about that. We wanted to generate keywords for short text based on abstracts, but actually in the company we wanted also to be able to generate keywords based on transcripts. So we wanted to quickly summarize a conversation. So this is another goal we had in our minds. So not only the abstracts, but also articles, news, conversations, basically everything. So we wanted to have an algorithm that will help us to do that. So keywords can be single words, but also multi-words phrases. They should be nominalizations are preferred, but of course not in all cases. So of course sometimes we wanted to have hashtag slogans like vaccinate yourself, or in some cases we wanted to have like general domain like postmodernism that will explain the article in the whole. Sometimes they should be lemmatized. For instance, if we have in Polish, this is very important because every word looks differently depending what we are saying. So if we are talking about the Tatra National Park, we can say, for example, Tatrzańskim Parku Narodowym, but we want to have a keyword Tatrzański Park Narodowy, not Tatrzańskim Parku Narodowym. So this is pretty important here to have properly lemmatized keywords, because we are doing it in Polish and English also. And they should be very precise, maybe not always complete, but precision is very, very important. So here are the examples of some Polish abstract and title and keywords. So we have some abstract about garden and some seeds and so on. And we have the word nasiona, which is of course in the keywords, and wydzielane enzymantyczne also in keywords. But we don't have tomato, paprika, and cucumber in the text, but it's in the keywords. So this is really guessing what should be there. And this is what I have to say. It's our work is partially sponsored by Kindly Cat Project. And we created a great corpus called Postmark. which consists from, this is a Polish open science metadata corpus, and we trained our model on this corpus. So we have different domains, engineering, social sciences, humanities, medical and health scientists, and so on. And we have over 200,000 of abstracts in total. So here you can see how many keywords we have here, and most of them are unique. So this is also a very complicated task because there is lots of unique keywords, and yeah, that's pretty difficult. So in comparison, Postmac to DAI, which is a directory of open access journals, there is not much of Polish documents. So this is really helpful when we want to train a Polish model. So there is around 17,000 of documents in DAI and 200 in Polish. So that's much better. Of course, in total, DAI is much better, covering 81 languages. So this is really nice, helpful. We also trained our model of DAI, but I will tell about it later. Okay, so how to generate keywords? So some of this you've seen in a previous talk, previous presentations. So we can do statistical methods like the TDF or KT minor. So we can look at the keyword frequencies and then guess which of them are important and which are not. And we can do key phrase extraction. So some people treat it like extreme classification problem. So extreme classification problem is when we classify a document into extreme number of categories, like 15,000 of categories, or 50,000 of categories. So that's a lot of categories. And in keyword assignment, each document can have 3 to 5 different keywords. So this is at the same time a multi-label problem. So multi-label classification is much more difficult than like classical classification, because the problem goes exponentially much more difficult. So some people treat it like extreme classification problem, and some treat it like binary word classification. So each word have assigned a score, like it was shown in the previous presentation. So each word is classified. If this word a keyword, so this is another approach. This extreme classification problem, Keyword is using that. Maybe you heard about it. This is a transformer-based model that compares embeddings, so like internet representation of the words, to find which of them are the most important. And here we are using keyword generation. So we are using text-to-text generative model, and we want to generate also keywords that are not included in text. Because, in the previous example, key phrase extraction, in binary word classification, we can only have keywords that are already present in the text. In case of extreme classification problem, we can have keywords that are not presented in the text, but this is a controlled vocabulary. In case of keyword generation, the vocabulary is uncontrolled, which can be a huge advantage, but also can be a huge downside, depending on the usage. And this is an abstract of our paper, our talk about the keywords generation. And those keywords below, you can see, are keywords generated with our algorithm. So we are talking here about extracting keywords, open metadata corpus of Polish science. So as you can see, it's a pretty long phrase, and the model generated that, and also T5 language model. So I think it matches the abstract pretty well. Of course, we could add a few more keywords, but those are pretty precise and work pretty well. Okay, so what have we did here? We used a text-to-text transfer transformer model called T5. So this is, how many of you have you ever heard about that, about the T5 model? Okay, so maybe three person here, 3 people. So this is a pretty kind of new model, a text-to-text generation model. Many people who work in NLP, in deep learning, they tried it or wanted to try it. So this is a encoder-decoder architecture that uses transformer blocks presented by Google. So, okay, encoder, decoder, whatever, but what are the advantages and disadvantages? This is maybe the most important thing for you. So first, it's very good with multitasking. So usually when we train a machine learning model, it does just one single task, right? It's usually trained to do one single task. But in case of type model, it can be trained to do multiple different tasks. So we can add a prefix, for instance, translate English to Polish and train the model to do that. And we also can prepare other prefixes like predict sentiment, and then the model will tell us the sentiment. So we can train one single model on multiple different tasks. But what is surprising, usually perform even better than model trained only on one task. Because when it's trained on different tasks, it learns some information between those tasks, and it helps it to learn better, your main task. So we use this model to add a new task, predict keywords. So this was another new task. So the advantage is that it's really easy to train because it's multitasking and it's text to text. You just need to put text inside and tell him what he needs to predict. So it's very easy. Put text, get out text, and it's done. So training is pretty easy. Of course, you need to prepare the text properly. It has to be clean, nice text. But if you have enough of text examples, it will work. So this is pretty nice. And it also achieves state-of-the-art results of multiple tasks. It works really good with translation. It works really good with many different tasks. Also, I think in subject prediction, it works pretty well. And as I said before, it allows to use one single model to handle multiple tasks. So it's also pretty useful from a production point of view, because you have one model standing and it occupies a bit of memory, but it's just one model. You don't have to have 10 models or 20 models and so on. But of course, it has some disadvantages. So we have to adapt each task we are using to the text-to-text generation problem. So when we have like subject prediction, it's kind of easy because the task is already text-to-text problem. But if we want to have some task like sentiment prediction, sometimes we would want to assign numeric labels instead of text labels. So we have to change it to text labels, and it's not always that easy to do. So not every task is very easy to convert it into text-to-text generation problem. Also, it has 2 times the number of parameters comparing to Barrett model and decoder of the GPT model. So here's disadvantage. I will also tell you a bit about disadvantages in our problem of keyword generation. So how did we train it? So first we got NT5. NT5 is multilingual T5 model. So this is a model trained on multiple different languages. It was trained by Google, so it works basically on any language. So this is nice. It was pre-trained on Polish by a Polish company Allegro, creating PLT5. And we used that PLT5, fine-tuned it for Polish keyword generation, and that's how we created it. So what was the input? Input was a predefined task prefix. So this was that I told you about. So keywords was our prefix. And then we had a title of the paper and abstract connected together. And we wanted to predict all of the keywords assigned by laborers, and those were comma separated. So this was our task. So if you want to check the demo, it's available on our website. Below there is a link. You can check it anytime. We have English and Polish demo there, so you can check it. And also, we have a fine-tuned model, PLT5 base, which we put on Hugging Face. How many of you know Hugging Face? Okay, a bit more. Okay, nice. So Hugging Face is a library and open website for models, language models, and also computer vision models. So any of you can download it. It's available for free. And many companies and universities share the models on the Hugging Face website. And there is also like MD5 base model, which we used, PLT5 base model, but also we shared our model there. Okay, so we trained it on pairs title and abstract to predict keywords. That's what I told you before. And trained it with new prefix keywords. It has really high precision, generates accurate keywords, and this is very interesting. We noticed that our model trained on Polish keywords and Polish abstracts have better results on English than existing methods trained on Polish and tested on Polish. So our experiments showed that. Because Polish, as I told you before, it's pretty difficult to predict keywords in Polish because of grammatization and everything. Polish have a pretty difficult grammar compared to English. So most algorithms that work pretty great on English very often doesn't work very well in Polish, even in trade. So this is how it looks like. We trained it only on 10 epochs, on those over 200,000 abstracts. So that's it, and those are the results. They might seem not very high. So in the previous talks, the metrics were explained. So P is precision, R is recall, and F1 is both precision and recall in the one metric. Okay, so what was our hypothesis about the T5 model? So we think that T5 models not only learns to assign labels from the domain of scientific abstracts, but also can identify and format potentially discontinuous noun phrases. So can the results be better in the corpus? We were asking ourselves, and we wanted to check based on some news examples. So here we have a short title of news we checked. It was about Polish minister that meets some German chancellor, and you can see here some examples from Keybird, Thermo.pl, Extreme Text, and PI keywords model. So I know it's in Polish, but as you can see, what's important in Polish T5 model, you can see if many words starts with capital letters. So we have Niemcy, which is Germany, Polska, which is Poland, and European Union, which is Unia Europejska. So the words are also lemmatized correctly, which is nice. Because in Keybird, for example, showed very strange keyword like będzie bardzo, which means it will be very. And that's all, it will be very. This is the keyword that's in the Keybird. So it sounds a little bit strange. Thermo.pl have quite nice keywords, but it's not very useful if we have almost 240 keywords, because Thermo.pl showed us 237 keywords in total. It's a bit too much to summarize the text. So it would be better to have just a few of them. And extreme text, very precise keywords, Russia, Poland, and European Union, but it doesn't tell us much about the article. And here are some examples of speech transcript. So we have speech transcript from some electrical company. And the customer is calling and saying that, okay, my electricity was cut off. And the keywords are electricity, power disconnection, and power outage. So this is also very interesting because we don't have the exact phrase of power disconnection in the text, but it's still here. So it's pretty nice too. So it works with transcripts as we wanted. Okay, so where can you test it? So on the Hugging Face, you have the link on the Voice Lab profile. You can see VL-defined-based keywords models, so you can download it and test it. And my recommendation is that check out our README and check out our generation parameters, because the parameters in the Hugging Face on their base websites are a bit off, so our parameters we suggest are much better and it works much better. Also, you can check online demo. So there is a bit difference between online demo and PLEN model on Hugging Face, because the model on Hugging Face was trained jointly on both languages, on both Polish and English. And our online demo was trained separately. So we have two models there. One model for Polish and one for English. So that's the difference. And we also have a paper about that, which will be presented in Vietnam this year. Also, if you want, you can use Carol to ask the model, and it's the same as a website demo. This is for people who like to type in the terminal. And yeah, that's it. So to summarize, our modified model was trained on abstract of scientific text and generally assigns accurate to incomplete keywords. It's able to format keywords correctly, like lemmatize, preserve capitalization, etc. And it composes discontinuous non-phrases, restores more frequent array, and that's it. It works with many domains. And we are pretty proud of that model. So that's all. Thank you so much.
Okay, Agnieszka, thank you for your talk. Questions from the audience? Yes,
It's a very simple question. I was just wondering, what's the difference between the VLT5 and the PLT5? What was the...
Okay, so PLT5 is a base model trained to, it was trained on the masked word task. So it was trained to predict next word in Polish language, but we trained our model to predict keywords. So our model is strictly trained to generate keywords, but PLT5 model is just model trained to understand Polish language. That's it.
So the one for the keywords would be the VLT5?
Yes, exactly. Like Voice Lab.
Yeah. That's it.
Someone else has got lost in the abbreviation models. Yeah, Jose, please.
Thank you very much for your talk. About the metrics in this course that you showed, you mentioned that they are rather low. However, I wonder what's the baseline? What's the random baseline for this task? Because when you have so many possibilities, the baseline basically is 0.001.
Yeah, so the baseline was the other result that was below ours. I mean, there was no single case of better results because we tested few algorithms. I think the extreme text was like 100 times worse. So it's a pretty big difference because the task is really difficult, and that's it. And when we are doing exact match, it's really difficult. I think even humans would have really low scores. Yeah. So this is how it looks like. And I think the best result was around 10 times smaller than ours. So that's it. In the paper, you can find the exact results. It's on archive also, so open. Thank you.
Any other question from the audience? I'm also monitoring the chat, but I do not see any other question.
I have a question to Agnieszka. So when you cooperate with the companies, let's say the insurance company, something like that, do they provide you with, do they describe their expectations towards the information exchange. So whatever they expect you to identify some keywords from their perspective, or do you also do that, or do someone else post-processes it to give what they want?
Actually, when we are working with banking domain, they have really strict expectations. That's true. Because sometimes they need to find some exact phrases. So this is maybe not every time that the 5 model will work the best for them, but sometimes they just need to summarize the whole corpus of conversations in a very quick way. So this is a great tool to do that, because you can just put like 1,000 hours of conversations. We will put it from through the ASR punctuation model and then to VLT5, and we can show them like top 100 keywords, and it summarizes pretty well everything what's going on in those conversations. So this is pretty useful, but they have really strict demands regarding topics and subjects and so on.
Because this is kind of a similar thing to when we would like to apply it to subject indexing, let's say, because we have some predefined expectation and control vocabulary. Right? So there's a question whether to do that before, to involve it in your pipeline, or whether to treat the outputs as the base for some mapping of control vocabularies and so on. Have the results.
I think it would be also interesting to train the model on controlled vocabulary, because when we are training it, I think we had over 100,000 of unique keywords. So that's pretty extreme problem. But if we will have, I would say, 10,000 of different keywords, maybe it will work a little bit more controlled way. So that would be helpful, I think.
Thank you.
I have 2 questions. One is that what if you have the full text? So is there a difference between the keywords generated from the abstract and from the text? If you did. And the second question is that what's the next step? So you did research. Next logical step would be create the service, right?
Yeah.
So do you plan it? And are you working together with Azure and which institutions?
Okay, so first I will answer the first question. So the question was how it works on a full text. Okay, so we actually tried it like 2 months ago on some humanities texts. So the thing is, well, even if it's a full text, we don't put whole full text inside of the model, because it would get the GPU memory to explode. So we cut it into shorter pieces, and we put shorter pieces inside of the model. So then we have much more keywords for the full text. So we can divide it in an abstract kind of length pieces, put it through the model, and then generate keywords. So we will end up with much more many keywords, but we also have other method called keyword aggregation that aggregates similar keywords into groups. So we can have, 40 keywords at the end, but do some keyword aggregation, and we will end up with 10 keywords. So sometimes it works good, sometimes not that good. Sometimes if it doesn't understand the text well, because it wasn't in the corpus, like some of the old humanities text we tested, it just gives a very general descriptor that matches most of the texts. Like, poetry or philosophy, because it will match probably it. So it guesses like that. So it doesn't work well with that, but it works kind of good when it extracts phrases from the text. And about next steps. So we are still planning to retrain our model. We are waiting for new corpus to train it, because we also tested it on DOI, and it's much bigger corpus, but the results were much more worse because the quality of data was also worse. So this is very interesting. So the die was 10 times bigger, but the results were much more worse. So this is interesting. So the quality of corpus is really important. So we are now waiting for a new corpus in cooperation here, and we hope we can help with our model to help annotating it automatically, the keywords in the metadata. So we hope, we can have some cooperation. Thank you.
Thank you for the questions. If there is no other question, both here as well as in the chat, so thank you.
Thank you.